share my screen. In case you don't see anything, just scream because I won't see your reactions. Okay.
So for everyone that's joining or is online on YouTube, welcome. Today we have Thorsten here that's gonna share a screen and we will be watching because he's gonna present his work on Emscripten. And yeah, have fun.
Okay, so I hope you can see my screen. Can you see my screen? Hope you can see my feedback on seeing my screen. Okay. So I'm going to talk about Emscripten Forge. So Emscripten Forge is kind of the combination of Emscripten and Conda Forge. And the mission is to add Emscripten to the Conda Forge universe. And I'm Thorsten Beier, and I work for WASM. So I'm Thorsten Beier, and I work for WASM. Is that something? Okay. So let me first talk about WebAssembly a tiny bit. Or WASM in short. So that's a binary instruction format for a virtual machine. And it's portable, such that you can compile or target it from many programming languages. And what you see in the code snippet is the text form of this binary instruction format. We just define a function which adds two integers together, returns the value. So WASM is really limited, so it in itself cannot do much. So it does not have a clock, it does not have access to your file system, and so on. So usually you want to embed it into something. This is Emscripten is kind of doing this. So what is Emscripten? So Emscripten is a compiler toolchain. Now with that you can compile C++, C or Rust, WebAssembly, and it's built on top of LLVM. Now, the thing is with Emscripten or WASM, you seldomly start to write new applications from the scratch. In WASM, you most of the time just compile pre-existing applications for the target WASM. So the mental picture of this can be WASM or WebAssembly itself is the architecture or the hardware, even though it's a virtual machine. And Emscripten can be viewed as the operating system. So Emscripten has some nice APIs. So if you use OpenGL, it will be translated to WebGL. It understands SDL, most of the POSIX specifications, and it can integrate or can communicate with JavaScript. It's relatively fast. So if you compile stuff with Emscripten, you get almost native speeds. It has some SIMD accelerations and threading. It's portable and can be run not only from the browser, but also from other WASM runtimes. Also, even though it's powerful, it has a lot of limitations. So it's a sandbox. So it has no access to your file system. The threading is also a bit limited. And also, you cannot do blocking downloads because it's from the browser. So most of the things which are when you try to download things, you need to do this async. So you enter in the async hell. And the download size of Emscripten binaries is also sometimes a bit big. Given all these limitations, people still compiled amazing things for with Emscripten for the browser. So of course there has to be Doom, right? Or other useful things like an x86 emulator running completely in the browser, so you can then run Windows NT or old macOS software. Or if you want to do even more useful things, you can run this emulator in an emulator in the browser. Or you can also run Python. For instance, Python can also be compiled to WebAssembly, and even quickly run that. So here we have a Python interpreter where we can, in the browser, do shenanigans with it. So yeah, and then there's also Jupyter Lite, which is in itself would be worth a complete talk, but Jupyter Lite is, in a nutshell, a Jupyter running completely in the browser, so no server somewhere in the background, and it uses kernels compiled to WASM with WebAssembly. And later there will be a tiny demo also of Jupyter Lite. So if you build stuff with Emscripten, it's mostly just cross-compiling, where Emscripten, WASM is like a target architecture. It's mostly Unix-like. Most things work. You can use CMake and make and so on. The workflow is usually, if you want to build a certain application, you start to build all the dependencies of the dependencies, and so on. And then finally, some executable as WASM. But since no one wants to build dependencies after dependencies on their own, like such a prefix, which you end up with if you want to build something, you could use Conda if you want to build a lot of packages. Just build your application and don't have to build all the dependencies by yourself. Probably most of you know Conda and Conda Forge. Conda is first, Conda is like a package manager you probably know, and there's Mamba and Rattler. And Conda Forge is a community effort to provide packages for this Conda universe. It supports Mac, Linux, Windows, a few other architectures. Unfortunately, WASM not yet fully. And this is where we started with Emscripten Forge. So Emscripten Forge can be viewed as a poor man's Conda Forge. So it's a single repository where we have about 200 recipes. And the recipes are built in the CI and uploaded to our package server here, where we have 200 packages, exactly 200 packages at the moment for Emscripten. And you see the packages, click on something and see some info. Yeah, how is this exactly done? So if there's a pull request to add a new package or to update a package, we just check in the pull request in the CI which recipe is changed. And then we build those recipes and upload the packages to this just mentioned package server. There are a few side projects connected to this. So there is this recipe repository, which are the recipes in itself. And since we are mostly interested in running, or we have mostly Python packages, you need a specific Python binary, so to say, which integrates a JavaScript foreign function interface. Even if you don't want to use JavaScript, for some things like async event loop and so on, since WASM does not support this on the fly, you need to do this via some JavaScript glue code. So it's almost mandatory that you have this JavaScript FFI. And then since Emscripten runs in the browser, testing can be a bit nasty because you don't want to fire up a window of a browser for testing and click through it by hand. So we have this code called PyJS Code Runner, which is like a headless browser, which can be used for testing. So a bit about the history of this project. So this was started in 2022 by Quantstack, by Wolf and me. And when we started, the recipes were still in some legacy format, the BOR format. And we had to do a lot of monkey patching to convince the Conda code base that Emscripten is a valid platform. And as I said, it was mostly Python packages. And this has a lot of limitations. The testing of the recipes used to be very hacky due to some limitations of what you could do with testing cross-compiled things. The local development was also not that easy, and it's you wouldn't think that that is so important, but there is no good, or used to be no good Fortran compiler for WebAssembly, and the favorite packages of some people like SciPy and others still use Fortran code. So this was a bit of a pain in the ass. But then we moved to Rattler build. This was good because it used already a newer recipe format, which I called here the Rattler format, instead of the BOR format, and this allowed some proper testing in the recipes. Why? The test dependencies we can now specify for the architecture we're building on, like my Mac, for instance, but also run dependencies for the architecture we are building for Emscripten, and this used to be impossible with the old format. And then we also added Pixie. This drastically simplified the local development, and I'm quite happy that we got a few new contributors because of that. Yeah, which was nice. So what can you do with it? So you can install packages just by calling micromamba and specifying that we want packages for the Emscripten WASM 32 platform, and list the packages we want. So what are the applications or the usages or what can you do with packages compiled to Emscripten? So there's Jupyter Lite. Jupyter Lite is like this in-browser Jupyter Lab, where the kernels are compiled to WebAssembly. And with that, you can so we have here a demo repository where we build everything. And what you can see here's an environment file. And in this environment file, we specify the dependencies we want to have from Emscripten Forge. So we also add Emscripten Forge here as a channel. And this gets deployed, and we can run the Jupyter Lite completely in the browser. Let me start the kernel. Outputs. And it's working. So we see the send of Python, and we can do stuff like that. And to show you that this is actually running in the browser, let's change the color here to green. And you see another smiley face. So you can create your own custom deployments of Jupyter Lite. So I actually can also show this probably directly here. So if you want your own deployment with your own environment, what you can do is you can just click here on this repository on use this template, and then create new repository. And then we create a new thing called hello world, demo, whatever, and create a repository. Oh, oops, there's the owner. Now this will create the repository, and all we have to do now is enable that this repository will be use the GitHub Actions to upload to a GitHub page. So we go to Pages and say deploy from GitHub Actions, and now we will see that our Jupyter Lite deployment will be built. This will take about 2 minutes to get to a running web page, so we will not wait for this, but this can be running in the background. Okay, so then you can pretty much do the same with Pixie. Recently, I think Wolf set up this pixie.toml where you can create custom deployments of Jupyter Lite, but everything is in a Pixie script. Then another application which is more or less brand new is the Jupyter Lite terminal. So in normal Jupyter, you have access to a terminal where you can run terminal commands, where you can run normal binaries, and we have the same for Jupyter Lite. So this means all the binaries which run in this terminal are compiled with Emscripten Forge, and we have things like grep, lua, and so on. Here we'll not give a live demo because this is brand new, it might not work, but here's a tiny demo. So this is running completely in the browser, so no server in the background, and we have here something which looks like a terminal where you can interact with. And here on the left side, you see your file system. This is not your file system, but a virtual file system. And we can modify this and add some files or remove them, wrap into those files, and do even piping, name stuff, see what the platform is, and we can even run Lua. Python probably will also run in a few weeks, but for the moment we started with Lua, and you can see the output where we just call the factorial. You could try this already at this URL, but at the moment this uses shared array buffers, so you need to set some flags in your browser that this will work. Okay, so, and last but not least, this is probably the oldest example we have for Emscripten Forge, but it's still my favorite one. So since we have a Python compiled to the browser, we can manipulate web pages directly with Python. So you can access the DOM of the page running, and you can even manipulate this with Python. And to show this, I have a demo where I compile box2d to Python in Emscripten, and with that you can do like these nice things. So here we are downloading everything, and this used to be an old demo for EuroSciPy, but it's still quite nice. So for educational purposes, things like that is nice. You can have, let me show you something. You can have these physics simulations. And the cool thing is this is now really not only running in the browser, but here we have the code, and we can manipulate the code and say, okay, let's have 20 of those thingies, and see the changes right away. With that, you can even implement tiny games, which then directly run in the browser. Let me go to this tiny World of Goo clone I hacked in a few lines, where you can play around. And even though this is running in the browser's main thread completely, it's still quite usable. That's it for that demo. And that's more or less already it. So what's our vision for Emscripten Forge? So we want to make Emscripten, or Emscripten WASM 32 to be precise, an official target for Conda Forge. We're currently already working on that. So there's this Conda Forge enhancement proposal where we want to have a vote to make this official. And we already added Emscripten compiler to Conda Forge and started to compile the first recipes. Then at the moment, if you want to install custom packages, you cannot do this at runtime of the web page, but rather when you build the page. So when you make a deployment, you select the packages you want to have, and then you can deploy the page to a server, but then you cannot change the or install packages at runtime. But that would be really nice. But for that, we would need to compile Mamba or Rattler directly to WASM, such that install packages at runtime. And last but not least, we are working on better R support. So there's WebR, which is running R in the browser. So we know that this works. And now we want to add R support also to Emscripten Forge. And the core language is already built. So we're looking forward to make this even more prominent. Yep. And that's it. Thank you for your attention.
Amazing. It's really good. I want to thank you because this is a really nice presentation. Thank you. I do have some questions for you actually. So who are you building this for? Is this specifically for Jupyter Lite or?
So Jupyter Lite was the when we started this, Jupyter Lite was the most prominent consumer which we're building this for. Or the people paying us to do that had interest in Jupyter Lite consuming packages from Emscripten Forge. Yeah. But now it's not like we only want to do this for Jupyter Lite. I would hope that this has some broader applications. I guess you saw the last example is not using any Jupyter Lite whatsoever, the one with the games and so on. So for educational purposes, I think this has also been a value outside of Jupyter Lite. Yeah.
Cool. Are there any more questions from other people? Otherwise, I have another one. So where would you see this in like 3 years from now? So you said you want better R support and stuff like that, but is there a longer term goal for this project?
I hope that in 3 years, Emscripten Forge will not a thing anymore, and it will be on Conda Forge, integrated in main Conda Forge. That would be really cool. And I think what is at the moment missing to make this really like even more valuable is this installing packages at runtime, because then you can just have a Jupyter Lite deployment and then install the packages on demand. And it's also not on a technical level, not terribly complicated, but there are a few things which need to be done, because you don't want to download repo data all the time if you open a website. So there has to be some smart caching and so on. And I hope that we get a few more maintainers. So Conda Forge works quite well because there is no single maintainer maintaining all the distribution. At the moment, I maintain a lot of packages on Emscripten Forge, so I hope that it will get adapted a bit more. If this becomes more a thing, then the package developers themselves can ensure that the package is built for Emscripten. At the moment, most of the packages we are building were never designed to run in Emscripten or in the browser. So yeah, and you see that when building the packages, that there are a few problems here and there. So it would be cool if this becomes more a thing, that everything gets more streamlined.
And would it, for that reason, also be something for the future where it would become normal to build for a WASM, so you wouldn't have to build for all the other platforms anymore because you can run it on any system, right?
I think this is, in the theory, that would be super nice. In practice, I think the limitations of Emscripten are still too big. I mentioned that there is some threading, but also the threading is limited. So if you deploy a page on GitHub Actions, for instance, then you get some specific course headers, which basically, or let me formulate different. So if you want to allow threads, then this can become a security issue. So you have to restrict the pages you deploy a bit more. So most of the times you don't have threads, for instance. Then you don't have access to your file system, just a virtual file system. That means if you reload the page, like stuff could just vanish. So you need to save the things in a smart way in the browser. Even though things are relatively fast, they're like, you would not want to do this for number crunching. Like it's probably still a factor 2 or 3 slower, even in the best case scenarios. But I think the main purpose of this is like educational purposes and documentation. So you can just if you go on numpy.org, you can try numpy directly, right? Because it's using the WebAssembly compiled version of numpy, so you can try things out quickly. Yeah. And if you do teaching, this is really useful because everyone who has ever taught a Python course, usually the most time is consumed by setting things up. There is always this one guy with a weird setup where you cannot install stuff and nothing works. So in that case, you could just point him to a website and things would work. And for a beginner's Python course, it does not really matter if it's fast or not.
Yeah, makes sense. Yeah, thank you. Again, is there any other questions from the rest that joined in Discord? And I see someone unmute. And he muted again. That's fine. So I really want to say thank you, Thorsten. It was a really great presentation. It was recorded, so we will also be able to, to keep it for the future and send it around to people if they want to know more about all this work that you're doing. Thank you, and I hope to see you again very soon. I will stop the recording now, but if there's any more questions, anyone, please join in and ask on our Discord. And hopefully we can get you in contact with Thorsten if you want to know something specific. Thank you.
Thanks. Thank you for your tools. They make life easier. Great. Then see you guys.